Hello, good morning, students. Today we will start the unit number 1, that is minimization technique. Let us see the contents in this particular unit. The first point is the logic design minimization techniques. The minimization techniques are of by using Boolean functions, second by using K-maps, and third one by using Quine-McCluskey methods. These are the three minimization techniques we will discuss in this particular unit. After that, next point is the representation of signed numbers with the help of sign magnitude representation by using 1's complement and by using 2's complement forms. Then third point we will discuss is the sum of product and product of sum forms. These are also the standard minimization techniques. That is, we can call these techniques as SOP, which is nothing but sum of product, and second is POS, that is product of sum, by using K-map techniques. These are the contents we will cover in this particular unit, that is nothing but the minimization techniques. Now, let us see first the introduction about digital systems. As name indicates, digital system contains digital signals or bits. Data in the form of bits is represented with the help of bits 0 and bit 1. See, this digital system supports binary data as logic 1 or high, that is positive voltage, is represented with the help of plus 5 volt, and second one logic 0, that is 0 volt, it is represented by low. Means in positive logic system, plus 5 volt is used to represent logic 1 and 0 volt is used to represent the logic 0. Now, second digital system is the negative logic system. In this system, logic 1 is represented by negative voltage and logic 0 is represented by 0 voltage. Thus, there are two logics which are used in the digital circuits or digital systems are nothing but positive logic and negative logic. The digital system is basically defined with the help of Boolean expressions or with the help of truth table or by using state diagrams. The requirements of inputs of the gates can be reduced by simplifying the Boolean expressions. There are three simplification techniques or methods such as Boolean method, K-map method, and Quine-McCluskey method. These are the three simplification or minimization techniques which are used in the digital circuits. Now, before starting or going in detail with different minimization techniques, let us discuss about basic Boolean laws. First one is the commutative law. Here, the any binary operation which satisfies the following expression is referred as the commutative operation. In first example, A dot B is equal to B dot A. We can change the sequence, that is A dot B is same as B dot A. Similarly, in second expression, A plus B, we can write or represent as B plus A. That is nothing but the commutative law. Second law is the associative law. In first example, in a bracket, A dot B dot C is equal to A dot in a bracket B dot C. Similarly, for second expression, in a bracket, A plus B plus C can be represented as A plus in a bracket B plus C. This law states that the order in which the logic operations are performed is irrelative as their effect is the same. That is nothing but the associative law. Third one is the distributive law. As A dot in bracket B plus C can be represented as by multiplying A in the bracket as A dot B plus A dot C. Okay, now next is the AND law. AND law is used to indicate AND operations. Therefore, they are called as the AND laws. AND law indicates multiplication property as A dot 0 is equal to 0. By multiplying 0 to any number or any variable, we get answer as a 0. Second, A dot 1 is equal to A. Output depends on the value of A because A may be 0 or may be 1. That's why there are two conditions, 0.1 or 1.1. That's why output A.1 is equal to A. Third AND law is A.A is equal to A. Instead of A square in digital systems, repeated variables are considered only once. That's why A.A is equal to A. Now in fourth law, A inverse or A complement, which is equal to 0. These are the four AND laws. Now fifth one is the OR law. OR law indicates addition operation or addition operator. OR operator is used to indicate the OR laws. First one is A plus 0. We can write it as a because output depends on value of A. A may be 0 or 1. 0 plus 0 or 1 plus 0. Answer depends on variable A. Second one, A plus 1 is equal to 1. Similarly, A plus A is equal to A. And fourth one is A plus A complement is equal to 1. Means 1 plus 0 condition or 0 plus 1 condition, we get answer as a 1. Now, sixth Boolean law is the inversion law. This law uses the NOT operation. That's why it is called as the inversion function or inversion law. The inversion law states that double inversion of a given variable which results into the original variable itself. That's why A double bar is equal to original variable A. A double bar equal to A. As we discussed six Boolean laws, now let us check the Boolean algebra. Boolean algebra can be used to analyze a logic circuit and expressions which are represented mathematically, and it plays an important role in a digital system design. Boolean theorems help us to minimize the Boolean equations. They are also known as single variable Boolean theorem or multivariable theorems, depending upon the number of variables used or involved in the given expression. Now, let us discuss De Morgan's theorems. De Morgan is a name of scientist. He derived two theorems, and these theorems are labeled as first theorem and second theorem. These theorems plays important role in the simplification of given Boolean expressions. The first theorem states that complement of sum of digital signals is equal to the product of its complements. That's why A plus B whole bar is equal to A bar dot B bar. Means NOR operation is equivalent to the bubbled AND operation. A plus B whole bar equal to A bar dot B bar. Similarly, let us discuss the second theorem. Second theorem states that complement of product of digital signals is equal to the sum of its complement. That's why AB whole bar is equal to A bar plus B bar. Means NAND operation is represented in the form of bubbled OR operation. These are the two De Morgan's theorems. In the next lecture, we will discuss the minimization techniques like K-map and Quine-McCluskey method.